Testing, testing. Good? Okay. Hi everyone, I'm Nate, and today I'm going to talk to you about HTTP, which is the common language of the web. You're probably familiar with the four methods that represent like a RESTful web interface. So put, get, post, and delete. But there are a lot of intricacies with HTTP. There's a lot of like wrinkles in the client to server transaction that I wanted to talk about. And given that the specs were just changed for the first time in 16 years last year, I thought it would be a good time to dive into HTTP and what's changed about it. So the crux of HTTP is that every client, if it wants to communicate with the server, has to send out a request in a way that the server can understand. And that server has to send back a response in a similarly like uniformly formatted message. So every request is going to have a start line and headers. The start line has the method, so what you want HTTP to do for you, and it's going to have the location of the resource. The headers are about like content negotiation, like how you want the server to bring this information back to you. On the response end, the server also has to send out a start line and headers, but the server always has to send a body as well, unless you use the head method that I'll talk about later. Okay, so when you type in a URI into your browser, the first thing that happens is the browser is going to split it into the scheme, the server internet address, and the name of the resource you want to access. The server internet address can be thought of as like an alias for the actual IP address of the server, in the same way that like 5 Hanover Square is an alias for the lat long of full stack. So it's important also to understand like where HTTP fits into internet architecture. So the best mental model that I could surmise here is that like HTTP is layered over TCP. So we can think of HTTP as a car. TCP is like the roads that it travels over, and IP is like the coordinate system that the roads are layered over. And beyond that, the data link layer, I think, would just be like Earth or some like physical representation. The only complication that makes this model a little bit inelegant is that every time that the HTTP like passes over TCP, the TCP connection opens and closes. So the TCP connection does not stay active after the messages have been transmitted. Okay, so there are 5 components of HTTP that I wanted to briefly touch on during this talk: proxies, caches, gateways, tunnels, and agents. These are the 5 like intermediaries that will make like the transaction between a client and a server less of a one-to-one request and response transmission. Proxies and caches are by far the most common. They are going to be like almost every site that you visit is going to send you to at least 2 proxies on the way. So how does HTTP find its way to a proxy? You can either set up a proxy on the client side, which would be like an explicit content proxy would filter out all like adult content from the server coming back to the client. Or on the server side, you could have a proxy that filters out malicious attacks. Like it's often used for security, to sort of like intercept traffic and ensure that it's valid. Because there are often more than 2 proxies in a chain, it's often important to like debug what's happened to a request along the chain. So there are 2 ways to really like suss out what's happening to the message. The first is to run the trace method, which shows you like along the proxy chain how the request is being altered. So in the previous slide, I had this anonymizer proxy. When this message gets passed through the anonymizing proxy, it strips it of the cookies and other identifying information and just passes this message onto the server. So in this case, trace would show you that the identifying information was removed from the request at this proxy. The via header is just a list of the different proxies in the chain. Another really popular type of proxy are just caches. These are just like storehouses of popular documents on a site. So one reason that this is incredibly popular is because if you're accessing a server from the other side of the country, there's enough space between you that the speed of light becomes a speed consideration in terms of file transmission. So like, if everything is moving optimally and a resource is only taking the speed of light to travel back and forth, that's still a round trip of 30 milliseconds. And if you have 250 images on the page, that's going to add up to a noticeable lag. So what happens is a site will cache the resources on closer servers and actually serve up those resources to you rather than having the request go all the way across the country. The most important consideration here is how fresh what's on the cache is compared to what's on the server. Because if you have like a resource on your site that was updated a year ago, but the cache is 2 years old, then HTTP needs to know that like the document that it's serving up is fresh and doesn't need to be revalidated. So if sometimes there are headers on the request message that are like explicit about when a resource is going to expire, but if that doesn't exist, then HTTP can just like algorithmically determine whether it's a fresh document. And this is a flowchart of what happens. Basically, when the request comes in for a resource, the server is going to check if it's a cached resource. If it isn't, then it will fetch it from the server, add it to the cache, serve it to the client. If it is cached, they check if it's fresh. The server checks if it's fresh. If it's not, it revalidates it, updates the freshness of the document, and serves it to client. Okay, so gateways are another wrinkle in the server to client model. Gateways are used when you want to communicate with an HTTP protocol or one protocol, and the server you're trying to communicate uses a different protocol. So the server might be an FTP server, and you want to access it through the web, so you want to use HTTP. It has to go through an HTTP to FTP gateway. Okay. There isn't a huge disparity between how tunnels work and how gateways work. Tunnels are basically just allowing you to transmit data in one protocol across another protocol. So like SSL will be transmitted across the HTTP protocol to the server. And the reason this is important, at least the reason why like HTTPS uses this method, is because if that message is ever intercepted, it will just read as encrypted data. Like the SSL is still traveling across the HTTP protocol, but because it's encrypted, if it's ever intercepted, no one can decrypt that. Okay, so yeah, here I just talk about how like a web firewall that only allows web traffic through will stop SSL unless it's traveling across an HTTP protocol. Okay, similarly, this slide is just about, okay, so I guess what I should explain further is that before SSL can travel across HTTP, it needs to perform something called a client handshake with the server, where the client and the server are essentially just agreeing on a way to encrypt the data. That way, only the server and the client know which encryption algorithm they're using, which is usually symmetric cryptography. Okay, so very quickly, I just wanted to review some of the changes with the new protocol that was just introduced last year. HTTP messages are now transmitted as binary data instead of textual data. The headers are compressed, which is a really important consideration for mobile. And servers are now able to push content proactively into a client cache. So if you request an HTML page and that page links to several source files, or like a CSS, a style sheet or something, the server will know that you're going to want to fetch that eventually. So it will just send that file over along with the initial HTML that you're requesting. Okay, and so these are some of the resources that I used. I think by far the most helpful resource for understanding HTTP is the network tab of the Chrome DevTools, because it will show you every HTTP request that you're making on a page and the amount of time that that request took and everything. Okay, thank you.